So the last part of our lecture is some application, including some notations that you need to be familiar with. These notations are used a lot for standard normal distributions in general and other distributions as well in reality. Okay, so the first notation we would like to talk about is the percentile notation. Okay, so P. So this P usually has a subscript to the right of it, okay, such as P's of 80. This is talking about 80th percentile. 80th percentile. You probably have heard about this percentile when you talk about the height, person's height in certain percentile, right? Or weight or person's like SAT score at a certain percentile. So this is talking about, actually this means the value of z with certain area to the left, okay, to the left. Now, if you have P80, then it's 80th percentile, talking about 80% of the area to its left. If P12 is talking about the 12th percentile, so 12% of the area to the left. P53 talking about the value of z with 53% of the area to the left. So in general, if you see subscript with P, okay, percentile, it always gives you the area to the left. Okay. Now, in contrast, we have another subscript with talking about the z, right? Z with a subscript, such as 0.2. So z is a 0.2. This is talking about the z-score. Still talking about the z-score with 0.2 of the area to the right. So the subscript after z always gives the area to the right. One gives to the left for the P, and the one gives to the right for the z. For the P, area to the left. For the z, area to the right. Okay. So we're going to show this as two examples. Let's first begin with the P. So we understand P of alpha is talking about the area of alpha to its left. So let's find the value of P of 80. Okay. So if you sketch a graph, oopsie, so let me activate my pen. Sketch a normal curve, right? This is talking about 80th percentile, okay, of z-score. So 80% of the area will be to the left of z. Okay. We understand here is 0, right, for standard normal distribution variables. So this will be 50%. 50%. For 80%, we need to go a little bit more, right? 30% more. So this is going to be your z, which is 80th percentile. They were asking you, what is the z? Okay. This area to the left of it is going to be 80% or 0.8. So again, just let's use the StatCrunch. Okay, StatCrunch. Okay, so we have the StatCrunch ready, and we understand to the left of my z, area is 80% or 0.8. So you should not be picking between because it's to the left. All right, so let's go standard. To the left is going to be smaller than, right? Smaller than. And the total area, which is the same as probability, is going to be 80%. So I'm just going to type 0.8 for the total area or the probability. Compute. This graph is consistent to what we have drawn for indication. As an outcome, we got this 0.8416 as the number, the outcome number, right? Okay. All right, so if we go back to here, go back to our PowerPoint slides, we should have P's 80th percentile. Okay, 80th percentile is P80 equals to 0.8416. So you can copy and paste this value. So copy and paste. Oh, it doesn't paste here in PowerPoint. So let me just copy in here. So I'm going to say it's going to be 0.8416. 0.8416. Okay, that's the 80th percentile. Okay, next let's do an example of z. Okay, z is of alpha. So for the z, as we have emphasized, z, the alpha area is to the right. So if we want to find the values of z's of 0.025, 0.025. So let's sketch a graph of normal curve. And 0.025, this small area is to the right of z. Okay, so it's a very small area, right? 0.025. And this is going to be z 0.025, right? And we can tell that z is definitely going to be positive, and it's probably going to be very close to 3. Okay. 302. So let's go to StatCrunch. StatCrunch. Here's my StatCrunch. It's to the right, so greater than, right? 0.025. So you type 0.025 here, and then you compute. You got 1.96, right? 1.96, close to 2. So z-score here, okay, the critical value is 1.96. Just be careful when you do the z, just remember area is to the right of your z. Okay, you'll be picking greater than equal sign in the StatCrunch. So in summary, the two major types of problems that we have been looking for is, first of all, find a probability. You'll be entering the value of z and find the probability. The other type of questions is find an inverse probability. So you'll be enter the probability and find the values of z. And both can be done in StatCrunch by using that window. So in the very end of our lecture, we want to talk about how you can copy and paste your output from the StatCrunch to a Word file for, say, homeworks to be graded if necessary. So if you've got this output looking like this, we can copy this entire graph, okay, entire output as a graph. Just go Options in StatCrunch, and then you go Copy. Once you have this copy down, you will be having an indication tip here. So basically, you right-click this image, and you say Copy Image. And if you want to paste it into Word, go open a Word file, okay? And we're gonna go like we're gonna say Paste, but then you do Paste Special. Okay, Paste Special. You can also do Alt-Control-V. Okay, Paste Special, and we do the second option. We do Device Independent Bitmap. Hit OK. So then you would have this outcome this output to be pasted into your Word file. This is necessary, for example, if you are doing test or homework assignments, you may need to attach this graph as a part of your work. Okay. All right, so that's the end of this chapter 6, part of the standard normal variable distribution. So let me know if you have any questions. Thank you.